Hello, my name is Jerry Ball, and today I'm going to be talking about a cognitively and linguistically motivated part-of-speech tagging system that we've developed and providing a quantitative assessment of what we consider to be a near-human scale computational cognitive model. This research was conducted in collaboration with Stuart Rogers from the Institute of Defense Analysis. The underlying theory is called double R grammar. Double R grammar is a computational cognitive grammar of the grammatical analysis of written English. It is focused on the grammatical encoding of referential and relational meaning. It is pseudo-deterministic in the sense that it processes the input and pursues the single best path given the current input and current context, but is capable of accommodating the evolving context. It is construction driven in that retrieved lexical items project constructions which drive processing. It is incremental and interactive in accord with well-established cognitive constraints on human language processing. It is large scale and functional, and as an example, the synthetic teammate project resulted in development of a synthetic teammate capable of interacting with human teammates in text chat. Given the focus on building functional systems, the focus is also on meaning determination. We view the traditional parts of speech as largely correct, but general and with no hierarchical organization. So parts of speech like noun, verb, adjective, adverb, and preposition are well established and we accept their validity. However, we need additional lexical knowledge to support grammatical analysis. In the case of nouns, for instance, we need to know whether or not the noun is plural or singular, and if it's singular, whether or not it is concrete or mass. In the case of verbs, we need to know information about the tense and aspect of the verb. We also need multiple inheritance and composite categories when the meaning of a word does not vary across different uses. For example, in the expression John is fast, the word fast is functioning like an adjective, whereas in the expression John ran fast, the word fast is functioning like an adverb. But since there's no difference in meaning across these two uses, we have created a composite adjective or adverb category for words like fast. In double R grammar, parts of speech are organized into a multiple inheritance hierarchy with composite categories. At the top two levels, there are 18 parts of speech which correspond closely to the traditional parts of speech. In total, there are 56 parts of speech with at least one lexical item associated with the part of speech. As another example of a composite part of speech, we have the preposition or conjunction part of speech for words like before and multi-word units like as soon as. In he arrived before me, the word before is functioning like a preposition that takes an object argument. And in he arrived before I left, the word before is functioning like a conjunction that takes a clausal complement. Since there's no obvious difference in the meaning of before in these two different uses, we have created a composite preposition or conjunction part of speech. It's important to note that not all prepositions can be used to conjoin two clauses. The main high-level part of speech categories in double R grammar include the high-level proto-noun category with subtypes noun, proper noun, pronoun, or nominal, the high-level proto-adjective category with subtypes adjective and adverb, the high-level proto-verb category with subtypes verb and auxiliary verb, and we also have the categories preposition, determiner, conjunction, and negative, which do not have a higher level category. Currently, we have a part of speech called interjection, but it's possible that this category is better represented as a grammatical function rather than a part of speech. So when you say, do you hear me? And the response is copy a verb or an interjection? Better represented as a verb or an interjection. In do you hear me? I copy you. Clearly, copy is functioning like a verb, whereas in do you hear me, Roger, if Roger is not an interjection, then it is unclear what the part of speech of Roger should be. In terms of lower level part of speech knowledge, for proto-nouns, we include information about the main grammatical features, including number, gender, person, case, and animacy. And in case of proto-verbs, we include the following main grammatical features: tense, aspect, voice, polarity, and modality. The part of speech of a word in a given use depends on multiple sources of information. An important source of information is the meaning. It is our claim that there should be no difference in the part of speech without a difference in meaning. Morphology is also a key indicator of part of speech, but is not always definitive. In the expression, my parents are entertaining, is the word entertaining a verb or an adjective? Well, if we say my parents are very entertaining, then the occurrence of very before entertaining is compatible with an adjective. On the other hand, if we say my parents are entertaining the neighbors, then the occurrence of the object, the neighbors, after entertaining is compatible with entertaining being a verb. Syntax is also important to determination of the part of speech of a word. But it's important to note that words can exhibit multiple grammatical functions in a given part of speech. For example, in the expression the ball, the word ball is a noun that functions as the head, whereas in the ball bearing, the word ball is a noun that functions as a modifier. Likewise, in the bull is running, the word running is a verb that functions as a head, whereas in the running bull, the verb running is the word running is a verb that functions as a modifier. We need to distinguish the part of speech of a word from its grammatical function in a given use. We also have a mental lexicon, which only includes frequently occurring words in a given part of speech. We currently have approximately 100,000 words and multi-word units in the mental lexicon. The perceptual form is also important for part of speech determination. However, the focus of double R grammar is not on perceptual processing. However, we do include information about the capitalization of words. We claim that our approach is cognitively motivated in the following senses. We use the ACT-R cognitive architecture for development. ACT-R is based on 45 plus years of research in human cognition. We adhere to well-established cognitive constraints on human language processing, including incremental and interactive processing. Given the incremental nature of language processing, there is no access to the right context. We select the best option given the current input and current context, but the system is capable of accommodating the evolving context through a non-monotonic mechanism of context accommodation. For example, given the input John kicked me, the word me is recognized as the object of kicked. On the other hand, if the expression continues as John kicked me the ball, the word me is no longer the object, it is the indirect object, with the ball being the object, and the processing mechanism is capable of accommodating this. We also avoid cognitively implausible mechanisms. There is no staged or pipelined analysis in double R grammar. So there's no tokenizing stage that provides the input to part of speech tagging, that provides the part of speech to syntactic analysis. These different stages are integrated in double R grammar. There is no fully parallel processing at the sentence level. Since there's no access to the right context during incremental processing, the entire sentence cannot be considered in parallel. And we do not use big data well beyond human capacity. Our linguistic knowledge, the linguistic knowledge encoded in double R grammar, is targeted and symbolic. However, we do bypass low-level perceptual analysis. There currently is no encoding of information about letters, phonemes, syllables, or trigrams. However, capitalization is represented. Perceptual processing in double R grammar uses Java code and regular expressions outside of ACT-R, but lexical retrieval is within ACT-R. We also claim that our approach is linguistically motivated. Basically, we claim that traditional grammar is largely correct in its assumption that multiple criteria are needed to determine the appropriate part of speech for given use of a word. That information can include information about the perceptual form, phonological in the case of spoken input, orthographic for written input, information about morphology, grammar, and meaning. We also adhere to the basic principles of cognitive grammar, which we assume improves on traditional grammar. In cognitive grammar, traditional parts of speech are meaningful but coarse-grained or abstract. We also adhere to principles of construction grammar, which represents linguistic knowledge as constructions, where constructions are pairings of form, function, and meaning. In R grammar, words are represented as lexical constructions. Explicit knowledge of lexical and grammatical constructions is represented as ACT-R chunks, and implicit knowledge of how to integrate constructions is represented as ACT-R productions. We also incorporate some aspects of generative grammar. In particular, we make use of X-bar theory and the grammatical functions head, modifier, specifier, and complement. However, R grammar is a bipolar theory in which the specifier is the locus of relational meaning. In the expression the book, the specifier the determines that the expression is an object referring expression. Whereas in John has kicked the ball, the auxiliary verb has determines that the expression is a situation referring expression. On the other hand, the head is the locus of relational meaning. In the expression the book, the head noun book indicates that this expression is a type of object, whereas in John has kicked the ball, the verb kicked functioning as a head indicates the expression is a type of relation. We also adopt elements of generative grammar like binding theory, trace, and pro. However, some aspects of generative grammar are rejected, including the claim of autonomous syntax and claims of functional heads. In our view, the functional head hypothesis is wrong-headed. As an example of a R grammar representation, we took the input from Lewis Carroll's Jabberwocky. "'Twas brillig and the slithy toes did gyre and gimble in the wave," and submitted it for analysis and got this final this result. We have highlighted the parts of speech in rectangles, and the unknown words we provide pointers to. And if you look at the unknown words, you can see that the parts of speech assigned to them are reasonable given the input. In terms of the quantitative assessment, the computational implementation accepts previously unseen, unedited, and unannotated input from single words to entire text. We use the concept of a free morpheme to determine the number of tokens. For instance, in the expression state of the art, we view with spaces between the words, we view this as 4 tokens, but 1 multi-word unit. On the other hand, state of the art with hyphens is also considered to be 4 tokens and 1 multi-word unit. The expression bin Laden's, on the other hand, is considered to be 2 tokens, with bin Laden being a multi-word unit that is in the mental lexicon, although bin Laden's is not. And a word like P period I period is also treated as 1 token, and it is a single word with embedded punctuation. For assessment purposes, we use sampling techniques. The samples need to be small enough for manual evaluation, but large enough for reliable statistics, and the sample should be representative of the underlying population. We collected 2 sample corpora book abstracts, where each abstract is on a different topic with different main characters. The intent here is that these abstracts are representative of the larger population. We submitted each abstract for analysis. Overall, we achieved 98.5% accuracy with a 95% confidence interval of 97.95% to 98.90%. We tagged 2,565 out of 2,604 tokens correctly. We believe this result is state-of-the-art for a cognitively and linguistically motivated part of speech tagger that does not use machine learning over an annotated corpus or deep learning over big data. In terms of comparison to competing approaches, The state of the art for machine learning and deep learning systems trained on the annotated Penn Treebank corpus is approximately 98%. Unfortunately, our results are not directly comparable. For one, their R grammar uses a different set of part-of-speech tags. The Penn Treebank corpus has 36 tags organized into a flat listing with no internal structure, whereas R has 56 tags organized into a multiple inheritance hierarchy with internal structure. For this study, we did not use the Penn Treebank corpus. The Penn Treebank corpus is pre-tokenized and all sentence boundaries are identified. Our corpus was not pre-tokenized and sentence boundaries were not identified. We used the concept of a free morphing to identify tokens, whereas the Penn Treebank corpus is pre-tokenized. In terms of future directions, we are working to develop metrics to support direct comparison to Penn Treebank trained systems. For this comparison, we want to add missing vocabulary from the training sections of the Penn Treebank corpus to support direct comparison to the test sections. We also want to manually update the mental lexicon to eliminate errors that were generated by the automated expansion of the mental lexicon. And we want to manually add familiar vocabulary that is currently missing. We can also improve the regular expressions used in the perceptual bypass for the handling of unknown words, and we can also improve the prefix and suffix analysis for unknown words. We want to add a capability to process multi-word units that are greater than 4 words and with variable elements. We need this capability to process idioms like he, she gave me his, her word. This final slide, I have a picture of myself and Stu Rogers, who collaborated on this research, and a picture of the kickoff meeting for the follow-on project to the synthetic teammate project that I mentioned earlier. Thank you.